Okay guys, welcome. Here is the first video for our mystery. And since the mystery is all about the scientific method, that's what we're looking at. We know that there are different steps in the scientific method. My students, I taught them SCIENCE for the steps. So what we're going to cover here are just the 4 basic steps. First one, state the problem. Okay? What's the problem? That happens a lot in life. So let's say you go home and you flip on the light switch and nothing happens. No light. After you get over your frustration and you're like, oh man, now we get into the next step. Step 2, form a hypothesis. Well, what do you think happened? Why didn't the light bulb come on? Well, I think the light bulb's burned out. So my hypothesis would be something that starts with an if and has a then in the middle. If then. So I'm thinking it's burned out if the light bulb is changed, then the light will come on. Simple. That's all there is to a hypothesis. Look at what your problem is, come up with what you think will happen, and turn it into an if-then statement. Now, the next thing you're going to do is step 3, and everybody loves step 3. This is where you test the hypothesis, okay? You're going to experiment. Yeah! That's what everybody likes to do. So, come up with an experiment for your hypothesis. Now, for this one, very simple. You're not really going to do it over and over and over and over and over again. You're going to do something. If it works, hey, yay. If it doesn't work, then you know that you were wrong and you have to try something else. Okay? So, testing the hypothesis. Since we think that the light bulb is burned out, we remove the burned out light bulb and we put in a nice brand new light bulb. Okay? And we see what happens. Does the light come on? Well, if it does, then we form a conclusion. Even if it doesn't, we form a conclusion. Okay? So our conclusion at this point, the light came on. That means my hypothesis is correct. Yay! Hypothesis for if the light bulb does not come on, I was wrong. The hypothesis was not correct. Now I got to get something heavier, something deeper, something more, oh my gosh, I might have to call an electrician because there could be something wrong with the wall switch or the wiring. Lots of money. Way better if it was just this. But life isn't always like that. I just asked Miss Sissel in her car. Okay? Now, for this mystery, we have lots of students in the school. And one of them, her name is Deja Cleveland. Now, Deja was in the lunchroom, and she heard some boys arguing. They said that ice water boils faster than room temperature water. And she thought about that, and she thought, that's just like the stupidest thing I ever heard. I'm going to do my science experiment to prove that they're wrong. Okay? So let's look at how Deja used the scientific method in her experiment. Let's turn the paper around, and we will zoom everything up a little. All right. That should be good. So the problem, does the temperature of water affect how fast it boils? That's her problem. Now, this particular mystery, I don't like her hypothesis because it starts with I believe. Remember, hypothesis starts with if, then. So let's look at what she wrote and let's rewrite her hypothesis, okay? So she says, I believe hot water will boil faster than cold water. Sorry to leave the picture there. Put some papers down. So let's look at this. I believe hot water will boil faster than cold water. So what she's saying is, if the temperature of water is higher, then it will boil faster. Okay? That's really her hypothesis. Don't use I believe. Use if then. Scientists use if then. We try never to use I. Okay? It's always in third person, never first person. So third person. So her experiment. For my experiment, I used 1 quart saucepan and 3 1-cup containers, sorry about that, 1 cup of containers of water. I labeled the cups X, Y, Z. Cup X had ice water, okay, and its temperature was 40 degrees. Cup Y was filled with tap water and its temperature was 70 degrees. And Z was filled with hot tap water and its temperature was 120 degrees. She heated the pot by boiling water and then pouring it out. Then I poured the water from cup X into the saucepan and placed it on the highest setting on the stove. Okay, and she timed the number of minutes it took to boil and then did it for Y and Z. And you can see in her chart here 62 minutes, 43 minutes, and 24 minutes. Now, before we go on to her conclusion, let me point out, looks like she did this once. Once for X, once for Y, once for Z. That would get you an F in my class. And I'm sure it would not get you a good grade in Miss Beach's class. Okay? We said multiple times. So don't do it once. Not just once, people. Okay? No. I told mine 10, 12, 14, 16, and on. Okay? I want to see lots of trials. And I believe Miss Beach said something similar. Okay? You got to do it lots of times. The more data, the more accurate your results. Okay? If I asked every single student in the school a question, that's more accurate than I ask just one student. If I say, hey, what's your favorite band? And that student said, Sawyer Brown. I know none of you know who Sawyer Brown is. And so I said, the favorite band of students at DSMS is Sawyer Brown. Y'all would be all upset. No way! Okay? More responses gives you more data, which gives you a more accurate position to stand. Okay? So this is what we want. Multiple trials. So her conclusion, she said, based on my observations, I conclude that hot water boils faster than cold water. My hypothesis is correct. And then she has a little picture showing her pan and the XYZ cups. All right? So, now you're going to start your very first private investigation. Ooh, if I go that way, it goes in my face. Private investigation assignment, your PIA. So PIA number 1 is what we're going to move to right now. Let's have fun.